In this video, we'll be looking at the first part of how to solve logarithmic equations. And if you have not subscribed to this channel, kindly subscribe so that when we release a new video, you'll be the very first person to be notified. Now let's get started. So in example 1, it says that find the value of x if logarithm of x minus 5 base 8 is equal to 2 out of 3. So first, we have to write our question. And just as said here, we are looking for the logarithm of x minus 5 to the base 8, which is equal to 2 out of 3. So here we can see that it's in logarithm form. So what we can do here is to change to exponential form. If you have not watched our video on how to change from logarithm form to exponential form, you can click up there and watch. That's the introduction to logarithms. So having known that, we said in changing from logarithm form to exponential form that if we have the logarithm of a to the base b, which is equal to c, then changing to exponential form, it means that we are going to have our a coming to this side, and then our b is going to have the exponent of c. So that means that we are going to have a is equal to b exponent c. So using the same ideology here, then we can find the value of x. So with this one, it means our x now becomes the a here. So that is x minus 5, which is equal to 8 exponent 2 out of 3. So having known this, then we can see at the right hand side that 8 can be expressed as powers of 2. That is 2 exponent 3 can give us 8. So it means that 2 exponent 3 gives us 8. And then we have our existing exponent as 2 out of 3. So we have x minus 5 here. And to continue, still simplifying the right hand side of the equation, we can see that the 3 here, take off this 3, and we are left with 2. So that becomes 2 exponent 2. Now we have x minus 5, which is equal to, we know 2 exponent 2 is the same thing as 4. So making x the subject, then our x value now becomes 5 plus 4, that is x is equal to 9. And this is how we can find the value of x in this very first question. It's just the application of changing from logarithm form to exponential form. So now let's try the next set of questions. So in example 2, it says that we should solve 6 log 10x, which is equal to 30. So with this, you have to write our question, and just like we read, is 6 log 10x, which is equal to 30. Now at this point, you can see that the logarithm, so just like you can see in our question here, the logarithm base was not written. So it means that it has a base of 10. So at this point, you have to write the 10 here. Now to continue, we can see that the logarithm 10x base 10 has a coefficient of 6. So in order to find the value of x, then we have to divide both sides by the coefficient of the logarithm. So it means that 6 log 10x base 10 is equal to 30. And at this point, we are dividing here by the coefficient of the logarithm, that is 6, dividing here by 6. And we can see that this 6 is going to take away that 6. And we are left with log 10x base 10. And we can see that 6 cancels itself 1 and goes into 30 5 times. So it means we are left with the logarithm of, that is the logarithm of 10x base 10, which is equal to 5. Now here, we can see that it's in logarithm form again. So we are going to change to exponential form. So in exponential form, then our 10 is going to come this side, and then the base 10 is going to take the number 5. That is an exponent form. So it means we are going to have here as 10x, which is equal to 10 exponent 5. So here, we can see that 10 exponent 5 is the same thing as 100,000. So we write here as 100, and the other 3 zeros continues. So we repeat the left hand side, that is 10x. Now at this point, we can see that we can divide both sides by the coefficient of x in order to find the value of x. So dividing here by 10 and also dividing here by 10, then we can see that this 10 cancels that 10 and this 0 also takes away that 0, and we are left with x to be equal to 1, 0, 0, 0, 0. So that is 10,000, and that becomes the value of x in this equation. So if that is clear, then let's try the next example. So in example 3, it says solve the equation log x exponent 2 base 10 plus log 2 base 10, which is equal to log 50 base 10. And in this equation, all the bases has been indicated. So we all know that they are in the base of 10. So now going straight forward, then we have the logarithm of x exponent 2 base 10 plus the logarithm of 2 base 10, which is equal to logarithm of 50 base 10. Now, just like we learned from the laws of logarithms, we said in the laws of logarithm that if we have a logarithm on the same basis and then the logarithms are adding, that implies that we are going to multiply the argument. So let's do this quick recap. So we said that if you have the logarithm of a plus the logarithm of b, then definitely, since they all have the same base, then we can multiply the argument. So that becomes the logarithm of a dot b base 10. The dot indicating that the argument a and b are multiplying. So having known this, then we are going to apply the same analogy here. This is just the application of the laws and properties of logarithms. So here we can see that we are going to have something like logarithm of x squared multiplied by 2, which is equal to the logarithm of 50 base 10. And not forgetting that the logarithm of x squared by 2 has a base of 10 here. Now we can break it down and make it of this way, that we have logarithm of 2x squared base 10, which is equal to the logarithm of 50 base 10. Now we can see that they have the same basis of 10, and what we can do here is to take antilog of both sides. So what we can do is take antilog of both sides, like we said earlier. So you have to write here taking antilog of both sides simply means that taking the antilog of both sides simply means that we are taking away the logarithms, and that is going to help us get the arguments and solve for the value of x. So taking antilog simply means that we are going to write out the logarithms. So in this case, you have 2x squared, which is equal to 50. Now with this, we can see that when we divide both sides by the coefficient of x, then we are going to be left with x squared. And when 2 cancels 2, we are left with x squared, and 50 divided by 2 gives us 25. Now we ask ourselves, what must we do here? Now here we have to take the square root of x squared and then the square root of 25. So this square cancels that square root and we are left with x, which is equal to, now the square root of 25 you all know to be 5. And this becomes the value of x in the third equation. Now we are moving forward to the next set of examples, and that happens to be in example 4. So example 4 says that find x when log x base 2 is equal to 3 minus log x minus 2 base 2. Now with this, we can see they have the same basis. So that is very clear, and we want to find x. So which simply means that first, you have to write our question as log x base 2, which is equal to 3 minus the logarithm of x minus 2 base 2. So here we can see that we can group like terms. That's the logarithms at one side and then the non-logarithms at a different side. So it means that we are going to have log x base 2 maintained here, and when we transpose minus log x minus 2 base 2 to the left hand side, they are going to have logarithm of x minus 2 base 2, which is equal to 3 maintained at the right hand side. Now we can see that here that they have the same basis and the logarithms are being added. So simply means that we can write one of the logarithms and multiply the arguments with the same base 2, which is equal to 3 here. Now we can see that it's in logarithm form, so you'd have to change to exponential form. So the exponential form, we can see that our x multiplied by x minus 2 is maintained, and this 2 is going to have an exponent of 3, that is 2 exponent 3. So here you are just going to multiply the brackets at the left hand side. So that is x squared minus 2x giving us, so 2 exponent 3 we know to be 8. Now here we are seeing a quadratic equation, and we can transpose the a to the left hand side of the equation, and that makes x squared minus 2x minus 8, which is equal to 0. Now here this is the quadratic equation, and the coefficient of x squared here is 1, and the coefficient, so now we are going to multiply the coefficient of x squared by the constant term minus 8. And when we multiply, we're going to find the factors of 8. Now when we add, we are going to get minus 2. And when we multiply, we are going to get minus 8. And the factors are minus 4 and positive 2, which implies that we can write them as x minus 4. And we have here as x plus 2, which is equal to 0. Now at this point, we can see here that we can solve for the value of x. That is when x minus 4 is equal to 0, then we have it as x to be equal to 4. And the other one, that is when x plus 2 is equal to 0, then we have it as x to be equal to negative 2. So we have our x value to be 4 and negative 2. Now remember in logarithms that we said that the logarithm of a negative number does not exist. So if you are looking for the value of x, then x should not be negative, because from the question was giving us the logarithm of x base 2, which is equal to 3 minus the logarithm of x minus 2 base 2. So now if you are saying that x is equal to 4, then means the logarithm of 4 base 2, which is equal to 3 minus the logarithm of 4 minus 2 base 2. Yes, it exists because our x value here is positive. Now when we take the negative aspect, that means that the logarithm of minus 2 base 2 is equal to 3 minus the logarithm of minus 2 base 2. And we know that the logarithm of a negative number does not exist. So here it means that the only value for x now is 4. So it implies that x minus 2 is not part of our solution. So therefore, you have to conclude that the only s value here is 4. So therefore, s is equal to 4. Now, if that is clear, then we go to the next example for today's video. So that is example 5. So example 5 happens to be the last but one example for today's video. And it says that if log 3x plus 1 minus log 3x minus 1 is equal to log 16, find the value of x. So we have to find the value of x. So we have to complete by saying find the value of x. So here, just like the question said, Then we have to write our logarithm of 3x plus 1 minus logarithm of 3x minus 1, which is equal to the logarithm of 16. Remember that the base is not written, so it implies they are of the base 10, the base 10, and the base 10 here. Now, applying the laws of logarithms, logarithms of the same base, when they are being subtracted, then we can divide. So simply means that we can write the left-hand side as a single logarithm as the logarithm of 3x plus 1 divided by 3x minus 1, all base of 10, which is equal to the logarithm of 16 base 10. Now here, what we can do here is to take antilog of both sides. So just like we did earlier on, taking antilog of both sides means that the logarithms are going to be taken away. This happens when there is equal to sign and there's not any other term apart from what we see here. So taking antilog of both sides, then we are going to have our solution as 3x plus 1 divided by 3x minus 1, which is equal to 16. So here we are interested in finding x. So by cross multiplication, then we have 3x plus 1, which is equal to 16 multiplied by 3x minus 1. So let's write our minus 1 properly. So you have minus 1 here. So now we continue by maintaining the left-hand side of it and expanding the right-hand side of the equation. So 16 times 3 gives us 48. So you have here as 48x minus 16. So here we can see that we are going to find x by grouping like terms. So we have 3x minus 48x, which is equal to minus 16 minus 1. So 3x minus 48x gives minus 45x, which is equal to minus 17, right? So that gives minus 17. Right here as minus 17. Now we divide here by minus 45. Also divide here by minus 45. So simply means that our 45 here is going to take away the 45. And the negative to also take away the negative. We are left with x, which is equal to, so negative takes away negative, we are left with 17 out of 45. And that becomes the value of x in this equation. Now we move to the last set of questions for today's video. And that happens to be, so we have in example 6, and it says that solve log x squared plus 1 base 10 minus 2 log x base 10, which is equal to 1. So here, you're going to write our question just like we just read. So that's logarithm of x squared plus 1 base 10 minus 2 logarithm of x base 10, which is equal to 1. So what we can do here is that we have to write the coefficients of log x base 10 as an exponent to the argument x. So that is the logarithm of x squared plus 1 base 10 minus, so logarithm of x squared, that is the 2 serving as an exponent to the logarithm, and this part of the laws of logarithms. So if you have not watched our video on the laws of logarithms, kindly click on the link above and watch it. Now we continue. So we have the base 10 here, which is equal to 1. So by applying the same laws of logarithms, logarithms of the same base being subtracted means that we can write it as a single logarithm by dividing the argument. So simply means that we have logarithm of x squared plus 1 all divided by the logarithm of x squared base 10, which is equal to 1. So we still have it in logarithm form, of which we can change to exponential form. So with this, it means that we are going to have our x squared plus 1 divided by x squared, which is equal to 10 exponent 1. We all know that 10 exponent 1 gives an answer of 10. So we are going to have at the right hand side here as 10. And we have x squared plus 1 divided by x squared. So here we are going to cross multiply. So when we cross multiply, that means we have x squared plus 1, which is equal to 10x squared. So you have 10x squared here. Now we can see that we can see like terms here and we can group them, which simply means that we can transpose the positive 10x squared to the left hand side, which becomes negative. So we have negative 10x squared, which is equal to also 1 being transposed to the right hand side, you have negative 1. So at this point, you can see that there is negative 9x squared here and we have negative 1. What we can do here is to divide both sides by the coefficient of x. That is, you have minus 9, minus 9. So simply means that the minus 9 takes the minus 9 out and we are left with x squared. And the minus also takes the minus out, we are left with 1 out of 9. Now here, what you can do is that you have to take square root of both sides, and that will help us to find the value of x. So that is square root of 1 out of 9. And we can see that this square cancels the square root, we are left with x. And we know square root of 9 is the same thing as 3. So we have here as 1 out of 3. And that becomes the value of x in this question. So basically, this ends today's video. And I believe you enjoyed this lesson. So, thanks for watching. Kindly like, comment, subscribe, and share. This is Bakumat, thinking beyond infinity.